Okay, so we're going to continue on with section 6.5, looking at rewriting trig functions where the angle measure is not a nice known angle measure on the unit circle. So let's take a look at cotangent of negative 5 pi over 12. Now, you might remember that if I asked you to do this on a calculator, you couldn't type in cotangent. What you'd have to do is you'd type it in as 1 over tangent of negative 5 pi over 12. Okay, and we're going to apply the same idea here. Now, the negative can stay in there or you can pull it out to the front. It's up to you. So I'm working with 1 over tangent. I'm going to go ahead and just leave it in there. Negative 5 pi over 12. Now, in order to have 12 in the denominator, we know we're going to have to use 3 and 4. Okay, so a pi over 3 and a pi over 4. Now, if we just left it as 1 pi over 3 and 1 pi over 4, we know that that would just get us 2 pi over 4. So in order to get the negative 5 pi over 4, I'm going to try that being a 2 and that still being a 1. And let's see what that gets us. So that would be 8 pi and 3 pi. Now if I do a minus sign here, that would at least get me to positive 5 pi over 12. Since I want it to be negative, I'll just flip-flop them. So I'm going to rewrite this as 1 over tangent of pi over 4 minus 2 pi over 3. Okay, so this is my alpha, this is my beta. Rewriting this, I've got 1 over, now this is still going to be a fraction in the denominator. So this is going to look like tangent of pi over 4 minus tangent of 2 pi over 3 over 1 plus tangent of pi over 4 times tangent of 2 pi over 3. Okay. Now, you have 1 on the top and you're dividing it by a fraction, so you multiply by the reciprocal. So this whole thing just gets flipped. This becomes 1 plus tangent of pi over 4 times tangent of 2 pi over 3 over tangent of pi over 4 minus tangent of 2 pi over 3. Okay, so using our unit circle knowledge up top, we have 1 plus tangent of pi over 4 is 1 times tangent of 2 pi over 3 is negative square root of 3. In the denominator, tangent of pi over 4 is 1 minus tangent of 2 pi over 3 is negative square root of 3. So this becomes 1 minus the square root of 3 over 1 plus the square root of 3. Not overly fond of square roots in the denominator, so we're going to multiply by the reciprocal. So in the denominator, we end up with 1 minus 3, and up top, we end up with 1 minus 2 square root of 3 plus 3. So we have 4 minus 2 square root of 3 over negative 2. Simplifying that, that becomes negative 2 plus the square root of 3. And there's our answer. Let's take a look at another one. So let's take a look at secant of negative pi over 12. This can be rewritten as 1 over cosine of negative pi over 12. And if you have cosine of a negative angle measure, that's really nice because the negative just goes away. So this is 1 over cosine of pi over 12. And based on what we did yesterday, we know that pi over 12 can be written as pi over 3 minus pi over 4. Well, and then we use our formula from yesterday. So I have the 1 on top, and then down beneath, cosine of pi over 3 times cosine of pi over 4. Since it's a minus sign here, it's a plus sign here. Sine of pi over 3 times sine of pi over 4. Alright, so up top I still have 1. In the denominator, cosine of pi over 3 is 1/2 times cosine of pi over 4 is the square root of 2 over 2 plus sine of pi over 3 is the square root of 3 over 3. I'm sorry, over 2 is what I meant. Times sine of pi over 4 is the square root of 2 over 2. So we're looking at 1 over the square root of 2 over 2 plus the square root of 6 over 4 my math's bad today. Sorry, guys. So this becomes 1 over the square root of 2 plus the square root of 6 over 4. 1 divided by a fraction, you flip that fraction, it becomes 4 over the square root of 2 plus the square root of 6. And we can't leave it like that because we don't like square roots in the denominator. So I've got 4, and I'm going to multiply that by the square root of 2 minus the square root of 6. And then in the denominator, square root of 2 plus square root of 6 times the square root of 2 minus the square root of 6. Up top, I'm just going to leave that 4 on the outside for the moment and see what happens in the denominator. Okay, when you multiply that, that becomes 2 minus 6. So 4 times the quantity square root of 2 minus square root of 6 over negative 4. And 4 divided by negative 4 is negative 1 times the square root of 2 minus the square root of 6. Distributing that negative 1 becomes the positive square root of 6 minus the square root of 2. Okay, now let's take a look at a slightly different problem. Let's say we've got this circumstance. Okay, so this is what we've been given. Sine of alpha equals 4 over 5. And sine of beta equals negative 2 over the square root of 5. Alpha exists between pi over 2 and pi. Beta exists between pi and 3 pi over 2. So take a moment, write those down. And the next 4 problems that we do will be based on this information. Now, since alpha exists between pi over 2 and pi, if you think about your unit circle, here's 0, here's pi over 2, here's pi, here's 3 pi over 2. So if it's between pi over 2 and pi, alpha is going to exist in quadrant 2. If beta is between pi and 3 pi over 2, that's down here. So beta is going to exist in quadrant 3. Okay. Now, 4/5 is not a nice point on our unit circle. So what that tells us is that we are not actually on our unit circle. Our radius is something other than 1. So we know that sine of alpha is y over r. So if I've got that y is 4 and r is 5, I need to solve for x. And the way we do that is using our equation for a circle, x squared plus y squared equals r squared. So I'm solving for x squared plus 16 equals 25. So my x value is going to be 3, but since it's in the second quadrant, it's going to be negative 3. So I'm going to need that. Looking at sine of beta, so when we're dealing with beta, the y value is negative 2. The x value is what I'm looking for, and the r value is the square root of 5. So if we do x squared plus y squared equals r squared, that's saying x squared plus 4 equals 5, x squared equals 1, x is going to equal negative 1 because it's in the third quadrant. Okay. Now find the exact value of each. Cosine of alpha. Well, if we want to know about alpha, we're going to use these values. And cosine is defined to be x over r. So that's going to be negative 3 over 5. To find cosine of beta, we'll use these values down here. So negative 1 over the square root of 5. And since they left the square root of 5 in the denominator here, you can do that here, or if it really bothers you, fix that to negative square root of 5 over 5. Either answer is fine. Okay. I'm going to go with this one. All right, so we know that when it's alpha, y is 4, x is negative 3, and r is 5. When it's beta, y is negative 2, x is negative 1, and r is the square root of 5. Using that information, okay, so I'm just going to copy it down again. You already have it, so you don't have to. The y value is 4, the x value is negative 3, and our radius is 5. So that's for alpha. For beta, y is negative 2, x is negative 1, and r is 5. Now down here, they're asking us to find sine of alpha plus beta. We don't know what alpha is and we don't know what beta is. But we do know how to rewrite this using the formula. So this is sine of alpha, cosine of beta, since it's a plus sign here, cosine alpha times sine of beta. Now, cosine of alpha is given to us. That's the 4/5. Okay. Cosine of beta, we just found it. It was negative 3/5. Plus, okay, now cosine of alpha, oh, gosh darn it, okay, cosine of beta, sorry, was actually negative square root of 5 over 5. Sorry, I was looking at alpha. I got ahead of myself. So cosine of alpha is negative 3 over 5 times sine of beta, which is given to us. I'm just going to fix it real quick and write it as negative 2 square root of 5 over 5. Okay, now doing the multiplication, this becomes negative 4 square root of 5 over 25 plus a negative times a negative is a positive 6 square root of 5 over 25. If you take negative 4 square root of 5 plus 6 square root of 5, you get 2 square root of 5 over 25. Can't reduce it, so that's your final answer. We did not have to know what alpha and beta are because we know that sine of alpha is 4/5, cosine of beta is negative square root of 5 over 5, cosine of alpha is negative 3 over 5, and sine of beta is negative 2 square root of 5 over 5. So as long as we know what the formula is and we have the x, y, r for both alpha and beta, we can figure this out. Okay, just one more here. Cosine of alpha minus beta. When we rewrite this, this becomes cosine alpha cosine beta. Since it's a minus sign here, it'll be a plus sign here. Sine alpha sine beta. Now, cosine of alpha is negative 3/5 times cosine of beta is negative square root of 5 over 5 plus sine of alpha is 4/5 times sine of beta, which is negative 2 square root of 5 over 5. All right, so a negative times a negative is a positive, so 3 square root of 5 over 25 plus 4 times negative 2 square root of 5 is negative 8 square root of 5 over 25. And if you take 3 square root of 5 plus negative 8 square root of 5, you get negative 5 square root of 5 over 25. The negative 5 and the 25 can reduce, so this becomes negative square root of 5 over 5. There we go. So this is combining two different ideas. First, we had to deal with the fact that our radius is not 1, so we have to figure out x, y, and r specifically for alpha. And then we had to figure out x, y, and r specifically for beta. And once we had all those values, we apply it to the formulas that we talked about yesterday to get our answers. So your assignment for tonight, it's in the textbook, page 509, numbers 34 through 40 even, 48 through 58 even. Good luck.